Hello everyone. In chapter 2, Hertzian contact stress, we are going to talk about the Hertzian contact stress. When two elements with curved surfaces make contact with each other and are pressed together, contact stresses, also called Hertzian contact stresses, are developed within the contact areas. Practical examples include the contact between wheels and rails, valve cams and tappets, mating gears, and roller bearing. Theoretically, the contact is either a point contact or a line contact. For prevention of this failure, please pay attention to this failure or pitting, we have to do these equations. You can calculate it by these equations or use unique graphs that we have presented here. These graphs. Since all teaching materials are from the book, this book, it's necessary I introduce this book, the book of design of machine elements, biographical methods for engineers and machine builders, third edition. By this book you can design every machine elements that you can need. You can buy this book, all the chapter in one book, or you can buy this book separately, each chapter from the Amazon site. Okay, let's back to our design. Example 2.1. Consider a crane that moves on a rail via rollers. Assume that on one of the rollers a force of 2400 kilogram is applied. Figure 2.3, this figure. The rollers and rail are made of CK45 steel with a hardness of 45 HRC. Check if the roller and rail can tolerate the load or not. As you can see, the diameter and the width of the roller are 50 and 60 millimeter. 50 and 60. And the width of the rail is 50. The width of the rail is 50. Okay. As we said, we need to find the allowable contact stress. You can use this figure. In this figure, we have two curves. From AGMA, one of them is n is equal 10 power of 8 and n is equal 10 power of 7. N is the number of cycles that the pitting occurs. Or you can use these areas are based on a GOSD standard. In figure 2 and 2.2 we find 45 HRC. 45 HRC, the stress of the hardness of the rail and the wheel. Please attention, if the rail and wheel have different hardness, choose the lower hardness. Select 45 and go up to cross the curve. For safety, I choose the lower limit. I choose the lower limit of the GOSD standard. This area is 4 HP more than 350, and this area is for HP lower than 350 Brinell hardness. Then we go to the left to reach the vertical axis. We go to the left to reach the vertical axis. The maximum allowable stress for the roller and rail is 1050 megapascal. Okay. For use of these graphs, we have to select from the left horizontal axis the force on the wheel. The force on the wheel is 2,400 kilograms. Therefore, we select this force from the horizontal axis. We go up to intersect the diameter of the cylinder, a smaller cylinder that is for wheel. Then we go to the left, to the right to intersect the length of the contact. The length of the contact here is 50 millimeters, not 60 millimeters. The smaller width. Then we go down to intersect the contact of cylindrical to flat surface, because the rail is flat and the wheel is a cylindrical part. After intersect this curve, we go to the left to find the stress on this contact. That is 850 megapascal. As a conclusion, as the estimated Hertzian stress that was 850 megapascal is lower than the maximum allowable stress. The allowable stress that was 1050 megapascal here. Therefore, they can tolerate the load and pitting will not occur. It's necessary I say about the parameter n. N is the diameter of the larger cylinder to the diameter of the smaller cylinder. For flat contact, the larger diameter is equal infinity. That is n is equal infinity. Okay, therefore you could design a rail and wheel easily by these graphs without any complicated equations that we presented here. There are some notes that is necessary I said you. All of these notes are available in the book. If the material of the wheel and the rail is different, for example, steel in contact with cast iron or aluminum, you can use the above diagrams, but you do not need a safety factor because the stress is about 1.5 times smaller than the steel to steel contact, because these diagrams are based on steel to steel contact. For plastic to plastic contact, you can use above diagrams, but you should divide the obtained stress, this is the obtained stress, vertical axis, by 10 for line contact and by 20 for point contact. We later speak about the point contact. Therefore, permissible contact stress for plastic is about 30 megapascal. The allowable contact stress, this is for steels, for plastic is 30 megapascal. For finding the allowable contact stress, if you don't have any data on materials, you can use the allowable contact limit of gears. You can refer to gear chapters to find the allowable contact limit of them. Here we spoke about line contact. For point contact, you can refer to the book, and in the book we speak about the point contact stress and some diagrams that help you to design point contact stress with an example of about roller coaster machine. Okay, thank you for watching. Please subscribe our channel and like the video and stay with us until the next book. Goodbye.